Can see my poster.
Yeah, if maybe you make it larger, yeah, on the parts that you would like to present. Yeah, it's good.
Okay.
Okay, thank you.
So good afternoon to all panelists and lecturers. My name is Pandaway from Environmental Engineering Department, and I will present my FYP poster now. My title is investigate the effect of incorporation of powder form plastic as partial cement replacement on the performance of concrete. As we all know that plastic waste is one of the most significant type of waste material in the world due to its non-degradation properties. The accumulation of large quantity of plastic waste has led to numerous of environmental problems, and the main way of dealing with plastic waste are landfilling and incineration, both of which will release the hazardous chemical into the environment. And at the same time, the cement industry release a massive amount of carbon dioxide into the atmosphere, posing another environmental problem such as global warming and greenhouse effect. So therefore, the use of plastic waste as partial cement replacement in concrete was suggested in this research because by recycling the plastic waste as cement replacement in concrete, the environmental problem generated from the plastic waste as well as the high cement consumption may be solved. So the objective of this research is to partially substitute cement with plastic waste powder in concrete, and then to investigate the effect of plastic waste powder in concrete by comparing the properties of concrete with and without plastic waste powder. And lastly, to determine the optimal substitution ratio of plastic waste powder in concrete, which range between 4% to 16%. So next, this is the flowchart of the methodology for this research. First, the raw material used in this research is cement, sand, PVC waste powder, and coarse aggregate. And there are four proportions of plastic waste are used as partial replacement cement, which are 4%, 8%, 12%, and 16% by weight of cement. So after we mix all the material together, a fresh concrete is formed. Then the fresh concrete test, slump test is conducted to measure the workability of concrete. So after the slump test, the fresh concrete is cast into three different shapes, which are cube, bean, and cylinder shape in order to carry out a different laboratory test. And then after casting of concrete specimen, the specimen are air dry for 24 hours. After 24 hours, the concrete specimen is cured for 7 days, 14 days, and 28 days in the water tank. So after that, the hardened concrete cube is taken out from water tank, and then the hardened concrete tests were conducted to determine the mechanical and durability properties of concrete. And the hardened concrete tests include the composite strength test, fractural strength test, water absorption test, porosity test, and gas permeability test. And then now we move to the result and discussion. So the result of this research will show the effect of PVC powder on the workability, mechanical strength properties, and the durability of concrete. And then for information, in the graph, the CS here stands for the contour specimen, which does not contain any plastic waste powder. And then the PWP for concrete. PWP4 is the concrete specimen with 4% of cement being replaced by the PVC waste powder, and then 8%, 12%, 60%. So now let's look at the effect on the flash property. The inclusion of the PVC waste powder has no effect on the workability of concrete when 4 to 12% of cement being replaced by the plastic powder. However, the concrete specimen with 16% of cement being replaced by PVC waste powder show a significant increase in workability. This is due to increased amount of free water in the mix when the amount of plastic powder increase, and this will result in the higher fluidity in concrete and subsequently increase the workability of concrete. Next, we continue on the mechanical strength property. The incorporation of PVC waste powder into concrete mixture for replacement of cement up to 4% can obtain the composite strength and fractural strength that is relatively similar to the contour specimen. However, the further increase of the PVC waste powder will lead to decrease in the composite strength and flexural strength in concrete. This can be attributed to the decrease in the amount of hydration production between cement and water, the low adhesive strength between the PVC particle and cement paste, as well as the hydrophobic nature of plastic particle, which blocking the movement of water. And then we move to the effect on durability properties. The use of PVC waste powder as partial cement replacement will reduce the durability of concrete because it will increase the porosity, water absorption, and gas permeability of concrete. And this is due to the decrease in hydration product, the calcium silicate hydrate CSH gel, to fill the pore and voids in concrete. And then this will result in the porous nature of the concrete, and then it will become more permeable and allow more air and liquid to diffuse through the concrete body. And then these are the SEM micrograph of the concrete specimen with different PVC waste powder substitution proportion. The first one is the micrograph of contour specimen, which does not contain any PVC powder. It can be clearly seen that the CSH gel was widely spread in the hydrated cement paste. And however, when we further look at other micrograph of the concrete specimen with PVC waste powder, it can be noticed that the distribution of CSH decreased with the increase in amount of PVC waste powder replacement in concrete. This is because of the lack of chemical reaction between the cement and plastic powder, which result in the decrease of CSH formation. And the conclusion for this research is the incorporation of plastic waste powder as partial cement replacement will increase the workability of concrete, but will decrease the strength and durability of concrete. The suggested optimal substitution portion of PVC powder waste for partial cement replacement is 4%, as the PWP for concrete specimen can obtain the strength value and durability that is similar to the M20 concrete. And the recommendation for future research are as follows. We can increase the substitution level of PVC waste powder in order to further explore the effect of plastic waste incorporation on the performance on concrete. And then we can extend the curing period to evaluate the mechanical and durability properties of concrete more accurately. And then we can conduct further study using different types of plastic waste such as LDPE, PET, HDPE. And then we can conduct more concrete characterization tests such as thermal conductivity and the sound insulation and the chemical resistance of concrete tests with the incorporation of PVC waste powder as partial cement replacement. So that's all for my presentation. Thank you very much.
Okay, thank you, Pan. Any question?
Yeah, I got one more question, sir. Can you go back to the slide?
Yes.
Okay, your porosity test, how do you conduct the porosity test? You just submerge into the water or what?
There's a gas permeability test machine in the Broadjet workshop.
Mm-hmm.
So and then there's how to say, a box to give me to store my concrete specimen, and then I apply the pressure on it, and then I use the shampoo to make the bubble inside the tube. So I record from the bubble from this distance travel to this distance. Use how many seconds. So and then I put this second into a formula and then calculate this porosity.
Okay. Did you break out your cube to study how much the penetration depth there will be?
No.
No.
Yeah.
Okay. Just calculate based on the percentage of the water, the ratio for the width only.
Yes.
Okay, understand. Thank you.
Okay.
Okay, thank you, Ayat, Darren. Any other questions from judges? All right. Okay.
Okay.